x equals opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. That is called the quadratic formula, and we've been working with this for a while now, using it to solve quadratic equations. So hope that's been helpful to you. We're going to look at some advanced examples today of how we can use the quadratic formula to help us solve quadratic equations. This is Mr. Schaefer, and good luck to everybody as we kind of work through these examples together. So grab a pencil and a calculator, and we'll kind of dive in together to some of these problems. Remember that we can't use the quadratic formula unless that equation is first written in standard form. So here's standard form of a quadratic equation. Ax squared plus bx plus c equals 0. Because then we can find a, b, and c easily within, or those coefficients in the constant can be found easily within the equation. Now remember too that the discriminant, which is b squared minus 4ac, that's this guy right here, that expression tells us how many solutions there are in the quadratic. You don't necessarily have to find the discriminant unless the problem is asking you a question about how many solutions there are, but that would be a part of the quadratic formula itself. We can see it actually right here under the radical. This is the discriminant in that quadratic formula. So once you substitute values into the formula, you can then get either your exact answer or a rounded answer with the calculator if there's some kind of simplified radical or square root expression that we can't evaluate easily. So with that in mind, I want to look at a couple examples before we start solving quadratics with the quadratic formula. And for these first 3 examples, all I'd like us to do is try to simplify the expression that's given here. So x equals, here's the first one, -8 plus or minus root 12 divided by 10. So I hope that you'd first of all see that radical 12 is not yet simplified, that in there I can write that as root 4 times root 3. And the square root of 4 is a perfect square, which becomes 2. So root 12 is simply 2 root 3. Now if we rewrite this as x equals -8 plus or minus, let's write that as 2 radical 3, all divided by 10, that would be a simpler solution or a simpler form for my answer for the quadratic formula. However, I want to show you this technique that I call Mickey Mouse reduce. It's kind of sounds silly, but Mickey Mouse reduce. Here's the idea. After you get a quadratic formula problem simplified down to this expression, what I want you to do is look to see if you can create a little Mickey Mouse here with ears. There's his body and his 2 ears. Look at the 3 numbers that I circled, the 3 numbers that sort of form a Mickey Mouse. Is there a number that will go in to each one of those pieces of Mickey Mouse evenly? And in this case, -8 and 2 and 10, the number 2 would go into all 3 of those numbers evenly. 2 goes into -8, -4 times. 2 goes into 2 once. And then 2 goes into 10 5 times. So my final answer after doing some clever algebraic reducing is really going to be this. X equals -4. Plus or minus will remain there. Instead of 2 root 3, it's just 1 root 3. I don't need to write the 1. It's inferred or implied to be in front of a radical with no coefficient. And then all that divided by 5. That would be the simplified sort of final answer for the problem. Okay, so that is the most reduced or the most simplified expression. So we kind of went from this initial problem here, simplify the radical first, got to that point, but then I can do this little Mickey Mouse reduce final step to get down to the most simple form right here, which would be my final answer. So let's try that again in example 2. Look to see if that radical can be simplified. Root 27 can be written as root 9 times root 3. 9 is my perfect square, so radical 9 becomes regular 3. So this root 27, I'm going to rewrite as 3 radical 3. So x equals 9 plus or minus 3 radical 3, and that's all divided by 6. Once again, think about using Mickey Mouse reduce. Here's Mickey Mouse. Is there a number that will go into 9, 3, and 6 evenly? And my hope is that you would figure out that the number 3 would work in this case here. 3 goes into 9 3 times. 3 goes into 3 once. And 3 goes into 6 twice. Now let's put together what we have. Solution would be 3 plus or minus 1 root 3, all divided by 2. And that is my most simplified solution. Let's do one more, and I'll do it even faster. So hopefully you can successfully follow along here. Root 48, be careful here, I want the biggest perfect square factor of 48. So if we split 48 up into 4 times 12, that will work, but 4 is not the greatest perfect square. There's actually a bigger one. How about we go with 16 times 3? So root 16 is a 4. Radical 48 can become a 4 root 3. Right there. All right, here we go. X equals 2 plus or minus 4 root 3 divided by 2. What number goes into Mickey Mouse? All 3 pieces. How about the number 2? Final answer, x equals 1 plus or minus 2 root 3 all over 1, but we're not going to write a fraction with a 1 in the denominator. So really, that just equals 1 plus or minus 2 radical 3. And that is your solution in most simplified form. So those examples are kind of a precursor set to solving these advanced examples using the quadratic formula. Let's go right down here to this next example. Solve by using the quadratic formula. So I have a quadratic equation. Let's begin by writing this in standard form. That's always going to be step number 1 if we're going to use the quadratic formula. So how about we subtract 4? 5x squared minus 10x. If I subtract 4 from both sides, I'm going to get a plus 3. And then equals 0. So first step, minus 4 to get standard form. Now it says here to find the discriminant. So I might actually do that in the formula. So I will do this in the formula. So you'll see that discriminant. The discriminant is b squared minus 4ac. I'll just do that as part of the formula over here in just a minute. All right, now we're ready. X equals opposite of b. Let's label the a, b, and c values. Here's a, here's b, and then there's c, the constant. Notice b is negative 10, by the way. Don't miss that negative. So x equals opposite of b. B is negative 10, so its opposite would be positive 10. There's opposite of b. Plus or minus b squared, so negative 10 squared is 100, minus 4 times a times c. All divided by 2 times a. 2 times a is going to be 2 times 5. All right, let's clean this up over here. There's my answer. It's just a matter of now using some algebra to simplify. So in the radical 100 minus, this is 4 times 5, which is 20. 20 times 3 is 60. So 100 minus 60 means in the radical I have a root 40. Solution, 10 plus or minus root 40, all over 10. Be really careful. Here's a caution. Don't do this and cross out the 10s and say, boom, my answer is plus or minus root 40. That is wrong. Be very careful. We are not allowed algebraically to reduce part of a numerator with a full denominator. That is incorrect algebra, incorrect cancellation. So be really careful that we don't do that. There's a warning for you. but rather stick to our process here with Mickey Mouse reduce in a little bit. But first, let's fix that root 40. In root 40, I can do 4 times 10. And radical 4 becomes a regular 2. So I have 10 plus or minus 2 root 10 all over 10. Now I'm going to make Mickey Mouse. What number goes into 2, 10, and 10? Well, how about the number 2 itself? 2 goes into 10 5 times. 5 times. 2 goes into itself once. So that leaves me with 5 plus or minus 1 root 10 all divided by 5. Once again, be careful that we don't cross off those 5s. That would be incorrect. We can't cancel that way. You're not going to break up part of the numerator without the denominator as well, so be careful. Okay, exact answers. Well, there they are. The exact answers would be 5 plus root 10 all over 5. 5 plus root 10 over 5. And 5 minus root 10 all over 5. If you decided to just leave this answer right here in the box, that would be okay too. That's perfectly acceptable. And rounded, well, we're going to type in this in the calculator. 5 plus root 10 divided by 5, that's approximately equal to 1.63. Decimal approximation, it's not exact, it's approximate. And then that other guy there, 5 minus root 10, and divide all that by 5, and our other solution would be 0.37, I believe, if you check that on the calculator. So there's a complete walkthrough of a pretty complicated quadratic formula problem, but we got there. We got to the solution in the end. So standard form, plug in A, B, and C into the quadratic formula, simplify, reduce your radical, Mickey Mouse reduce, and then write both exact and rounded answers at the end. All right, well, with one more example left, maybe I think we'll tackle this guy here. How about number 6 on this activity? So I'll move a little bit quicker, see if we know what we're doing, and see if you can keep up. All right, I'm going to add 10 to get this guy in standard form. So here we go, x squared minus 10x plus 22 equals 0. Let's use the quadratic formula. I'm just going to make a little mark here on my values. A is 1, B is negative 10, and C is 22. So I'll kind of color those in or label them. You can do that if you wish. A, B, C. All right, solution x equals opposite of B, plus or minus big square root of b squared minus 4ac all over 2 times a. And clean that up, 10 plus or minus. 4 times 22 is 88, so 100 minus 88 is going to be 12. 10 plus or minus root 12 all over 2. How about a little radical reducing right there? 4 times 3, or root 4 times root 3, which is going to be 2 radical 3. That's all over 2. And now I'm ready for Mickey Mouse reduce. Let's make Mickey Mouse here with my 3 little pieces, 3 numbers. What number goes into Mickey Mouse? How about 2? Final answer. 5 plus or minus 1 root 3 all over 1. And of course, we're not going to write that over 1. We'll just say 5 plus or minus root 3. And again, those are 2 numbers. 5 plus root 3 is one solution. 5 minus root 3 is the other solution. with my calculator, let's get the rounded answers. Add 5 plus root 3 together. Press enter and round to 2 decimal places. 6.73 would be that approximate value. And then I believe 5 minus root 3 is 3.27. So we really have, remember that these are the x-intercepts. Those are the solutions, which are also the x-intercepts. So if I were to graph this thing right here, I'd see x-intercept solutions at 3.27 right there. And then another one over here at 6.73. So graphically, we found x-intercepts. That's kind of the connection between parabolas and these solutions that we're finding. All right, so those are some advanced examples of how we can use the quadratic formula to solve quadratic equations. They can get tricky and pretty complicated. Don't forget to watch out for the case of no solution. If ever that number in the radical is negative, if our b squared minus 4ac is less than 0, then we have no real solution. So kind of watch out for that case too. Just one other thing to notice as we're working through these problems. Good luck to you as you solve quadratic equations using the quadratic formula.